Well, good day to you all. Yes, this is the Ask Academy. That's who we are. And we're going to be talking today some pre-calc, and we're going to be looking at some ways of being able to go over some review. We're looking at functions today. So functions is the name of the game today. We're going to be looking at some various facets of the function world. And so we're specifically going to be looking at examples of how to first take a relation, which is a collection of ordered pairs, where you have domain, which are the independent variables. They are the x coordinates that we look at, and we have a range. And if we're given that either in table format, or if we're given the set of ordered pairs in any other way, for that, we can look at how to determine if a collection of ordered pairs where you have -2 and -1 and 0, 1, 2, let's say that's your domain as an example. How do I tell if that is a relationship when I have -2 paired up with 5? When I have -1 paired up with 8? When I have 0 and 1 paired up with 6. And when I have 2 paired with 7. Now that's what we call a relation. It's a collection of ordered pairs, a collection of domain and range that are mapped to certain individual elements. Is this a function? And here's what I'd like you to think about. A relation is a function if all the x coordinates, all the domain elements, map to a one-to-one relationship with one unique y coordinate. Here's another way to think about that. For a relation to function well, the domain has to date be paired up with one and only one y coordinate. So if we look at the x coordinate here, -2, is -2. Do you see it dating or being paired up with anything other than 5? No. What about -1? Only 8. What about 0? Only 6. What about 1? Only 6. What about 2? Only 7. That makes that relation a functioning relationship. So, yipper, that's a relation. That's the relation is a function. Now, you may be saying, hey, 6 as a range element or a y coordinate is paired up with, is dating, is going out. You see it paired up with 0 and 1. Those are two different, but you don't really look at the dating habits of the y coordinates. You only look at the dating habits of the domains, the x's. Those are the only ones that have to be monogamous. They have to be paired with one and only one for a relation to be a function. So we're only looking at the dating habits of the domain. Okay, so that's whether your relation is put into that kind of communicated to you that way, or if your relation is communicated to you in table form, you're still going to look at the input, the domain, the x, and you're going to match up. You're going to identify or take their dating habits. See, 0 is paired up with -4. But 0 here is also dating +4, not a functioning relation. So we've had quite a bit of vocabulary: domain, range, relation, function. Those are things that we're using as a working way here in this course. We also have algebraic way of determining if a relation is a function. So what's the algebraic way? Let's say that we're given a function identified like that. And we want to know if that's a relation. Well, the first step that you do is isolate the y each time. So to isolate that y, we would move that -x² over there and add it to that 4. Once you've done that, the question for is it a relation is, can I plug anything in here for x and get two different answers where x would be paired up and dating to other individuals or to other numbers? And the answer is no. Any number I put in here for x, I'm going to square, I'm going to change the sign, add 4, and get one unique answer. But what if the equation started out this way? Again, I'm going to isolate the y, and so I'm going to get y squared, move the negative x squared again over there with the positive x, and then to get y by itself I got to take the square root. So when I take the square root of both of those, I get a situation where if I plug in a value for x, I'm going to take and square it, change the sign, add it to 6. I'm going to take the square root of that number, and anytime you take the square root of a number, you get two values. You get a positive and a negative. So anytime you have a square root, and the problem you're going to end up with, you do not have a function. So yes, this is a function. No, this isn't. Now here's the key. If you're looking at your original equation, anytime you have y being raised to an even power, y to the second power, y to the fourth power, y to the sixth power, your answer is going to be no. Now what's the y exponent? What's the exponent on the y here? It's 1. Or if it was y to the third power, or y to the fifth, or y to the seventh, if you have an odd power on the y, it's going to be a function. If you have an even power, it's not going to be a function. So you need to be, that's a good tip to determine if the function is if the relation is a function algebraically. Okay? Well, that's today's lesson. We are talking about functions. We're talking about domain and range. We're talking about algebraic sets. Is it a function? It's a function if the dating habits of the x's are monogamous. They only pair up with one y. We are the Ask Academy.